Good morning, good afternoon, and evening, everyone. My name is Maria Arevalo Sanchez, and together with my colleague Marcos Lopez-Caniego, we would like to show you the data contents and all the set of tools and services that are available at the European JWST Science Archive, which is being developed, maintained, and operated here at the ESAC Science Data Center in the European Space Astronomy Center, which is located near Madrid, here in Spain. Okay, so our team at the ESAC Science Data Center has been in charge of providing a European JWST archive, and it is acting as the official ESA repository to all the JWST public data holdings, and also supporting the European scientific community, but also open to all the scientists around the world to explore these precious JWST observations. So what are the data contents that are available at the European JWST archive? Well, within the established partnership that we have with NASA, the European Space Agency, and the Canadian Space Agency, we are making use of some common procedures and software tools in order to synchronize all the JWST metadata and data contents. And we are mirroring this way the Minkowski Archive for Space Telescope, MAST, within the JWST archive, which is maintained at the STSCI, the Space Telescope Science Institute. So our team at ESDC has developed a carefully designed graphical user interface to access the data contents, plus several backend services which are based on virtual observatory protocols, such as the table access protocol, which is our main backend to all of our services. And we are this way offering the access to both private data, which is stored at STSCI, and also the public observations that we are storing as well here at the ESDC. There is also a dedicated JWST section within the ESA Data Labs tool, which is the new science exploitation platform, which is developed by the Data Science and Archives Division here at ESAC. And we will now show you a demo of both of the user interface and data lab sections for JWST. Okay, so here you have the entry point to the JWST Science Archive user interface. This is the home page where we have a section on news, on the archive, and on JWST observations and data contents. We have a dedicated online search form, direct form by target name or coordinates, by proposal ID. We have access to the different sections of the archive, like the search, URL search, the user account, access to the help desk, dedicated JWST help desk. So let's go and jump to the user guide of the archive, where we can have an overview if you want to introduce yourself with the archive. We have access to the search page, instructions, how to download data. We have also some other sections, as the release notes for each of the versions we develop. We have some information about the James Webb mission. And we also offer a section where we give instructions on how to access, for instance, the early release observations, so awaited back in July. So we are offering here information on how to access by proposal ID all the data contents and observations from that data release. So let's have a look, for instance, at the Carina star forming complex, which is a proposal ID associated is 2731. So let's go back to the search and let's search by this proposal ID. If we click here, we have a list of options available. And the first thing we'll see is the available observation related with this program ID. This is the result table. We have here access to the postcard, some image visualizers. We have access also to the information at STSCI about the program details of this program ID. We have several actions to download, to change columns or add columns, etc. If we click in one of the observations, we'll get access to the details of this observation. So we have several metadata attached and details, and we have an instance of the ESDC widget, which attached to these details for the observation. We can plot all the footprints from the results we obtained. We can have a look at the metadata of the observations. We can have a look at the postcard that this observation has. And let's have a look now at the option that the ESDC widget offers. And we are putting this way the observations in context with other missions. If we open the full mode of the layout of the ESDC and we go to the outreach mode of ESDC, we will be able to overlay some nice outreach images prepared by the ESA web team. So let's keep one of them here on the demo. They are very cool if you can have a look at them. And let's now go back if we click on the scientific mode for ESDC, and let's use some options that we have available. We can select other skies. We can overlay image observations that are available in this section of the sky. For instance, here we can add Spitzer observations. We can have a look at the catalogs and sources that are available in this section of the sky. So here are all the Hubble source catalog 3D.1 version overlay. Also, we are overlaying the Gaia DR3 sources. Let's remove the Hubble source catalog one so we can see them better. And you can explore the sky with ESDC and many other options that are available. So if we go back to the results page, let's close the ESDC view, and let's have a look at one of the visualizers that we have developed for the FITS images. And here you have the FITS image data product available for this observation. We can zoom in within this image. We can explore the image, zoom out, and we can also change the settings and modify for instance, the color maps. We can modify the scaling, etc., etc. We can also go back to the initial status of the image. And let's go back to the results. And let's now have a look how to retrieve the data. So we could, if we click on the observation, we will open the shopping basket window, where we see here the access to the processing levels for this observation. If we want only the processing level, for instance, the selected one, which is level 3, we see all the products which are available, and we'll start the download directly from here, and we'll retrieve it directly in our browser. If we go back to the search page, let's look for another early released observation. And I want to show you here one of the data cube that is available with the data cube viewer that we have developed for the JWST archive. So you will see here that as we are downsampling and downloading the image and loading it into the cube viewer, we are able already to inspect what it has been downloaded. If we click in one of the points, we'll be able to inspect the spectrum for this point. Okay, so if we go back to the search section, we will have here additional filters to search for the JWST data. So we have basic search by coordinates and target form. We can select if we want private or public data. We can select which processing level we want to retrieve, and some other observation constraints like the observation ID or list of observation ID. We can retrieve which instruments do we want, also the attached observing modes. We can also search by proposal constraints like the PI name or the proposal ID. we can see that we are offering at the right side the current search that we are executing. So you see all the filters, also the equivalent ADQL query that is being executed, and the results you will retrieve with that search. We also have date filters. So if you select, let's select a moving target filter, and let's execute the search. And we'll see here a list of moving targets. So you can see here that we have private and public observation. The private ones are the ones with a red background. So if we wanted to retrieve some of them, we would need to sign into the EJWST archive. You can register as a new user. We have a self-registration page here. I will register with my account. If we go here, we will execute the search, and let's see what are the options available with being registered inside the EJWST archive. So if it happened that I had a valid MAST token, which gives me authentication against MAST products, I would be able to retrieve the data products which I am authorized by MAST to retrieve them via the EJWST archive. So as I don't have a valid MAST token, I will retrieve the public products. And let's see here that we have a big amount of products, so I can ask the JWST server to retrieve the products in asynchronous mode. So if I ask for using that URL for the products that I want to retrieve, when they get processed in the server, I will get an email with a list of data products that I will able to access at an URL that we prepared for the user, having a valid email on your user account for EJWST. So let's go back now to the options that we have in the archive. We have also we are also providing a custom instance for ESDC for JWST, on which we would be able to access the observation by instruments. So if we zoom out, we will see the mocks that are being ingested daily for the JWST observation, and we can see what's being observed by JWST for all the instruments that are available. So we see what has been observed by JWST. We have also started the automatic ingestion of the heaps for the public JWST imaging data. And we started with the early released observation, so that's why we are going to the cartwheel zone of the sky. So here, if we overlay one of the infrared sky, we will see what the heaps that are available in this region of the sky. So here is being loaded, so we can zoom in on this data product from JWST. We will also be able to overlay all the NIRCam observations on top of the heaps that we prepare. We have also an advanced search form, which is intended to use ADQL. So let me go back to the search form, and I want to show you that we also offer a method to retrieve the query that we are executing within the search form to be used with ADQL, with Coral Access, also in Astro Query. So if we copy the ADQL search within, we could come back to here to this section. This first tab is intended to enable a visual way of accessing the tables that we are exposing with tab. And here there is an ADQL editor where you have access to the published tables that we have in the JWST archive, and an ADQL section where you can run the query and you can keep your results. You will have access to all the metadata which is available in all the tables that we are exposing. If we go back to the guide, you will see that we have several information on how to access the data contents and metadata using scripting access and command line access. So we are exposing a lot of information on how to access with TAP, with the table access protocol. And we are also offering information on how to access the custom JWST Astro Query module that is also available for you, and with several examples on how to access data, how to register, etc. So with Astro Query, we will be able to enable the investigation in data labs, and Marcus will show us a bit how to do this.
Thank you, Maria. Okay, so what I'm going to show you is, well, Maria was showing how to access the data from the archive interface. Now I'm going to show you how you will be able to do this from ESA Data Labs. So this in this demo, I will start one of the various JWST areas that we have in Data Labs. This is the more general one, intended for general public. We have others that have been used for commissioning and GTO image processing. So I just started both the JWST and the DS9. It will take a few seconds until the image is retrieved from the registry and started, but it doesn't take more than a few seconds. So I already have my DS9 ready for later, and I go back to my Jupyter Lab instance. This James Webb image contains has several components. One of them is the official JWST calibration pipeline, and also access to a local copy of the calibration files for convenience for our users. But I will not demonstrate the calibration pipeline now. I will only show how to use the ESA JWST Astro Query module to access data via our JWST archive here in Madrid. So here I'm opening an example notebook that will show the various Python methods that we have to access the data. So one of the first things that I will do is importing the AstroPy and Astro Query, and then I will show how these methods want to do a concert and to do a query regions to search products by target name, and then these methods to get a product list based on some proposal ID to download, how to download the product, and how to open those products. Okay, so now what I'm doing is just like setting some coordinates, where I know there is some public data in eJWST. So this is this method, this concert, is several inputs. Here, as you will see from my example, it will be very simple ones, just the coordinates, a search radius, and a proposal ID, and also the calibration level. So I'm now executing first. I get all the available columns for these concerts. This is not very convenient because this is this table contains all the CAOM information, which is quite a lot of information, typically a bit advanced for the typical user, but it's good that we have access to this in such an easy way. So if I just restrict this view of the table to the few columns that I'm interested for this proposal ID, and now I will show you the results. So here I have some results for this proposal ID for NIRCam and MIRI. This is for proposal ID 2727. And then I'm going to get the list of products that are associated to one of these observation IDs. This is done with this get product list. Now for this, for each one of these methods, there is this help that you can get some of the details. Now I'm executing the get product list, so I see all the available products. Typically, I will be maybe just interested in the main science product. In this case, it will be an uncalibrated fits file that I will maybe process with the calibration pipeline myself. But then if I want to download just that product, then I will use the get product method. And that's just, as you will see, just very easily, it is just one line to download to your local phone the product. Then there is this other method, get ops products. This is also to get the whole set of products for using an observation ID. And then this is the line to get that. In this case, I'm just selecting for this particular observation ID all calibration levels and product science, product type equals science. So now for this, so these products have been downloaded, and then if I want to take a look to these products, I can do this very easily here within the notebook, as I will show in a minute. And then you can also do this in the DS9 that I open in a separate data lab.
There is about 5 minutes to go before the question.
Okay. So here I'm going a bit into the detail of changing some of these parameters, but maybe I can just go a bit faster. As I was saying, for one of these products, I'm going to just download all one of the observations, one of the files. This is the DS9 that I had opened before. I just go there and I can. This is a full instance of DS9 running on a separate virtual machine, so I can just go and open this particular product and then do the usual things you would do with DS9, which is really nice to be able to have this. In addition to DS9, we also have Aladdin and QFITS Viewer. So then one of the things that I wanted to show is that in order to do some additional work with this with the results of these queries to the JWST archive, I can get all the metadata and pipe it into an ESDC instance embedded in the notebook. So here what I did is instantiate the PyESDC, which is the Jupyter widget for ESDC, and then just as you will see in a minute, we have the possibility to overlay the footprints and to show the metadata from these queries into ESDC. So here so this is the result from the query region that I just did, and then I'm just changing the background to the NIRCam heaps and overlaying some NIRCam footprints, and then you have the data, this ESDC data panel at the bottom. And then another thing that we have in ESDC is the JWST planning tool that I can also start and operate from within the notebook, and then just which shows the various JWST instruments in the pocket there. And the other thing that I wanted to show very quickly is this pipeline. Some of this will be mentioned tomorrow in the focus demo from Vicente Navarro about data labs, the platform in general. So this is the pipeline editor, and I will show an example for the JWST pipeline. This will give the user the possibility to design or define their own pipelines. And then in this case, this is doing the 2 steps of the JWST calibration pipeline behind. And what this setup allows is to easily define and share pipelines with others. So here you define some input files, the location of the calibration files that we want to use. Also allows to do some to override some of the default CRDS files, and then very easily launch the pipeline and then just execute it. So here is just looking for an example data that can be analyzed. So I'm just selecting a file, selecting the location of the calibration files, and in just a few seconds I will be done. So this is just showing the location of the file to be analyzed. And then just define some output directory, and then you launch the pipeline. And then here in the ADASS dashboard, you see this triangle that is showing that the pipeline is executing at the moment. And then in about 20 minutes or so, these 2 steps of the processing pipeline will be done. I think we can start this demo now. Okay, thank you.
Thank you.